Okay, we will talk today about the discussion of Chapter 5, the present worth analysis. We will solve two problems in regard to finding the present worth when alternatives have the same number of years or if they have different number of years. This chapter, as is discussed earlier, is regarding to the present worth analysis when you have to make a decision for alternatives or even one option based on the liquidity you have now. So you conduct the present worth analysis to compare the alternatives, and you can make the decision based on that, whether using exclusive when you have a situation you have to select only one, or independent projects, that mean independent selection, you can select as many, or you do nothing, that means you reject either one option or all the options on the table. And the chapter also talked about when we have alternatives, we have to select one of them. We use the equal life alternatives method when all the life are equal for all alternatives, and we use one of the two methods, LCM or the study period, if we have different life alternatives for the options we have, and then the capitalized cost, which will be discussed inshallah in the next lecture. So today we will start with the question here we have for chapter 5, and I would like from you the participation in solving this problem. We have two alternatives, 1 and 2, whereas the first cost is given, and the first cost represent what? Represent a future or an annual or a present format. First cost, yes, represent the present. The annual operating cost, it is yearly based, so it is an annual. And pay attention that the annual, it could be annual income. So you have to read it carefully. Here, the signs are not given, as you can see, because you have to figure out whether the sign is minus if it's a cost, or if it's inflow or revenue, it has to be a positive. Now, the annual operating cost, it is 20,000 for 1 and 15. The salvage, which is the value that is at the end of the project or at the end of the life of the equipment, it is given usually and it is a inflow format. Yes, Raed, you have a question?
Excuse me, doctor, but the annual operation cost, can it come in negative, so it become a profit?
In that case, it will not be annual operating cost. Cost, it is a cost, so it is outflow. But it could be annual revenue. It can, instead of annual operating cost, it can be annual revenue. So you have to read what is given here. Don't assume that every time the annual, it is cost. AOC stands for cost, annual operating cost. And that is a cost, never gonna be inflow. But if it is annual revenue or annual operating revenue, then that is a positive and it's an inflow. So you have to read it carefully. The salvage, we all agreed from the beginning, salvage comes at the end of the lifespan and it is a positive value. It is inflow. The number of years are equal for both alternatives, which is 4. The interest rate was given as a 12%. A relation that correctly represent or calculate alternative 1 or 2 is requested. So I'm assuming now you can give me what will be the formulation for alternative 1 and what will be the formulation for alternative 2. So if we started with the formulation for alternative 1, let's do the text here, yes. So what will be the formulation, the present worth for 1 equal to? So what the formulation will be, we will start with the first cost. What is the conversion needed, if it's needed or no, for the 40,000? No need, so it is 40,000 going to be as it is. No need to convert it. It is already a first cost. The 20,000, it is excellent, Abdullah. It is B given A. Oh, thank you, Firas. Okay, that's all the formula. It was already wrote here. So 20,000 12% for 4 years, and plus 10,000 for the the salvage value that is given. And that will lead to, I will leave that to you to solve it and give me the answer. For the present worth for 2, it will be the same thing, nothing different, because they are equal in terms of the life years. The only thing, the value of the present, the annual, and the salvage will be different. 65,000 and minus the 15,000, be given A 4 years plus the 25,000. I would like from you to calculate this for me and find the final answer for each alternative, so we can decide which one has to be for each one of those. Okay, sorry for the voice was not connected. Now let's go back. So the second, it is 9,406. Let's do it here. So in this case, we select the first one because it has the largest numerical value. This is a minus sign, just to correct it, because the text box was stopped that time when the voice gone. Okay, it is a minus sign. And in this case, we select the largest numerical value, and the 94,385 has the largest numerical value compared to the 94,667. So this is for problem 1. Let's move on to the second problem, where we have a case of different life years, and in this case we have different values, and we are going to use the LCM, even though it didn't state that in the question, but in the exams it will be clearly that whether LCM or the study period to be requested, and it will be stated in the question. So if we are going to use the LCM in this case, usually the study period, even if it was given, it will be clearly that a study period has to be specified. It is not going to be for the students to do it. So let's do the how many alternatives we have here, how many solution alternatives we have for this company, and what are the given information. What is the LCM value for the number of years? All these questions, you can discuss it here in the chat box, or you can use the mic if you would like to, and we can proceed with the solution later. So let's start with the given information. How many methods we have, or how many alternatives? We have 3. Yes, because it says that the company has 3 different assembly methods, and each method has its own value. So the first alternative in this case, what does it have? What the given information? We have here 40,000, which is the first cost. Yes, excellent. And the 9,000, which is the annual operating cost. Good. Now, how many years for the first method? It is 2. Good. For the method B, we have the first cost is 80, and the annual is 6,000, and the number of years are 4. And the third one, which is the third method, we have the 130 is the first, and the annual is 4,000. Number of years is 8. And then there is a statement here, and you have to read it carefully. Method A and B will have no salvage value, but method C will have some equipment worth. Worth means that worth of a salvage value, estimated 12K, which means that method C only has a salvage and A and B doesn't have. Interest rate was given for a 10%. How much, or what is the LCM value for those 3 different years? We have year 2, year 4, and year 8. How much, or what is the value of the LCM? Pay attention. Firas, thank you. Excellent, Firas. Before you go for above numbers, 7, okay, I think by mistake. Okay, 16, I see where this happened. And pay attention. LCM doesn't mean have to be a multiple of all the numbers if one of them is already the LCM. When I have 2 and 4, 4 is the LCM for both numbers. It is a divisible. You can divide it by 2 and you can divide it by 4. When I have 2, 4, and 8, 8 can be divided in all of the 3 numbers. It doesn't have to be a number that above 8. But when you have numbers like the example in the slides of chapter 5, when you had a 3, I believe, and 4, in this case, 4 it cannot work. Also 8 it cannot work for both of them. Then you have to find a number like 12, for example, that can be divided by 3 and can be divided by 2 or 4. So here in this case, 8 considered to be the LCM. So how many cycle we will have for alternative 1? When we say how many cycle, that is exactly 4. So we will repeat values given for alternative 1 4 times, and for alternative 2 we will repeat it 2 times because we will divide the 8 over 4, so it will give us 2, and that is the 2 cycles. And the third method, which is C, it will not have any more than 1 cycle because it is already 8, the number of years. So to do the formulation for method A, PW1 equal minus 40,000 minus what? I would like here to have a help. If we are going to use method 1, the values will be repeated for 4 cycles. How many times the first cost will be repeated? 4. Good. In these 4 times, is it be present all the time, or it will be needed to convert it from a different format? In other words, is the 40,000 going to be at time 0 in all the coming cycles? No. Yes, Frost. Thank you. Why? Because 40,000 will be on year 2 in the second cycle, and it will be on year 4 in the third cycle, and it will be on year 6 on the fourth cycle. So how we are going to convert it in the second cycle? It will be minus 40,000 multiplied with P given F. Excellent, Ali. 10% for 2 years. And then minus 40,000 again for P given F. How many years? 4 years. Excellent. Minus 40,000 P given F for how many years now? 6. Excellent. Six years. To be for the first cost. What about the annual cost? What will be the conversion for the 9,000? Be given P given A. Excellent. 10% for year 8. And that will lead to, I will lead you to calculate it while I do the second method. The second method, it will have only 2 cycles because LCM is 8. 8 divided by 4 is 2. So we will repeat the values only for 2 cycles. First, we have first cost, which is 80,000. Then the 80,000 again will be repeated as we did for the first step, P given F for 10% for How many years? The 40,000 or the 80,000 for, sorry, for the option 2 or method 2. The second cycle will be for how many years? 4. Yeah, excellent. 4. No salvage, then that's all. No, we have what we missed here, what we are missing. What are we missing here to complete the formulation or method 2? Should I call names here, or you will give me what is missing? What is missing here? What are we missing? The formulation for method 2. We had the first cost, the annual operating cost. Thank you, Ali. 6,000 multiplied with F, a P given A, or 10%. How many years, Ali? 8 years, excellent. Okay, I will leave this also for you to find the answer. I will call random names to find me the table value, so pay attention now. I will go to the sheet and get random names. So stay, have the tables next to you. For the third method, it will be only one cycle because the number of years only for one cycle. And that will lead us to the 130,000, which is the first cost, and no need to convert it. It is already on the present. And then we have the 4,000, which is P given A for 8 years. And there is a salvage or no? For alternative 3. P given F 10, yes, exactly. So it will be plus the 12,000, which is the salvage, P given F for 10%, and 8 years. That will lead to, so let's take the first answer was, someone here did it. It was minus 60,000. No, I believe like that. No, it is not 60,000. So P equal to 170,970, and P it will equal to minus 166, 649, and PW3 equal to minus 145, 742. And comparing those three alternatives, you select the least common, the least value, numerical value. We have minus 170, minus 166, and minus 145. So which method should we select based on the present worth analysis? Method 3, exactly, because that is the largest numerical value. That was the solution for this problem. If you have any questions, you can send it here or use the mic, and we will continue later with the capitalized cost and the payback. That is all for this part. I will take now the questions and do the attendance.